minus sin alpha 1, sin alpha cos alpha 1, cos of alpha plus theta minus sin of alpha plus theta 1. Operate R3 goes to R3 minus cos theta times R1 plus sin theta times R2. We get delta equal to cos alpha minus sin alpha 1, sin alpha cos alpha 1, 0, 0, 1 minus cos theta plus sin theta. Expanding with the help of last row, we get 1 plus sin theta minus cos theta times cos square alpha plus sin square alpha, which becomes 1 plus sin theta minus cos theta. So delta is equal to 1 plus square root of 2 times 1 by square root of 2 sin theta minus 1 by square root of 2 cos theta, which can be clubbed together, becomes 1 plus square root of 2 into sin of theta minus pi by 4. But sin of theta minus pi by 4 lies strictly between minus 1 and 1. Multiplying by root 2, we get minus 2 root 2 lies between root 2 times sin of theta minus pi by 4 less than or equal to root 2. Adding 1 to each, we get 1 minus square root of 2, 1 plus square root of 2 sin of theta minus pi by 4 is less than or equal to 1 plus 2, 2. Therefore, 1 minus square root of 2 less than or equal to delta less than or equal to 1 plus square root of 2. Hence, the range is 1 minus root 2 and 1 plus root 2 closed interval. If T1, T2, T3, T4, T5 be in AP with common difference D, then the value of the determinant T2, T3, T3, T4, T4, T5 in the first column, T2, T3 and T4 in the second column, T1, T2, T3 in the third column is equal to lambda times D raised to power 4, where lambda is equal to 1, 2, 3 and 4. These are the 4 options. We know T1, T2, T3, T4, T5 are in AP. Therefore, T2 minus T1, T3 minus T2, dash dash dash, their difference is equal to D. Also, T3 minus T1, T4 minus T2, dash dash, their difference is 2D. Hence, the given determinant is T2, T3, T3, T4, T4, T5 in the first column, T2, T3, T4 in the second column, T1, T2, T3 in the third column. Operate. R2 goes to R2 minus R1 and R3 goes to R3 minus R2. We get first row as T2, T3, T2, T1, T3 times 2D, D and D, and last row T4 times 2D, D and D. Again operate R3 goes to R3 minus R2. We obtain T2, T3, T2 and T1 becomes the first row. T3 into 2D, D becomes the second row. 2D into D, 0, 0 becomes the third row. Expanding with the help of R3, we get 2D square times T2 times D minus T1D. Pulling out D common, we get 2D square into D times T2 minus T1, which is again D. Therefore, the product is 2D4. Hence, lambda is equal to 2 and option B is correct.